Hi to everyone. In this video, we are going to discuss about the simulation of forward kinematics of Mitsubishi MoveMaster RM-501. It's a basic level industrial robot. It is also named as articulated robot due to its rotational movement in all three rotary directions with all 6 degrees of freedom. The important concept in this simulation is about implementation of forward kinematics animation. That is, the position of particular parts of the model at a specified time are calculated from the position and orientation of the object together with any information on the joints of an articulated model. We just go through this simulation part of the site. This is simulator screen in short. There are 5 options we have in this simulation portion. That is input joint values, transformation matrix, controller, manipulation position, and finally simulator. Fine. The input joint values. Input joint values are used to identify the geometric relationship between the input and output motion parameters of this MoveMaster RM-501 robotic arm. The output here is nothing but this transformation matrix, formation of transformation matrix through which a relationship is established between different links of this manipulator. Generally, RM-501 drive unit provides the intelligence and control for the robo unit. The drive unit computes all the arm control information for each instruction. It handles arm velocity, acceleration, deceleration, and movement trajectories for the user. The drive unit is interfaced to the computer host processor through a controller interface. Inserting various values of theta within the joint range as recommended and click OK to the output orientation and position of the end effector. For instance, I just give a value about 20 degrees here, and here it's about 30 degree, 40 degree, whatever it may be. If we are giving the range of this theta is between minus 45 to plus 45. If we are giving a different value, it gives a negative impact, it won't give the value. Now if I click OK to this button, the output orientation and the position of the end effector can be found. This is the transformation matrix results. The transformation matrix locates the result here. For instance, if I am giving a 50 degree angle here, what happens? It gives the negative range. There is no kinds of output. That is the position of the end effector we are not finding, because that is the range prescribed by the user. But now we get into the next thing. This is about the third one is about the controller. When you are discussing about this controller, to see the individual movement of the links, drag the slider on the controller panel. The teaching box allows the user to manually move all the joints of the robot unit and store positions as desired. For instance, waist joint, the range of this waist joint is up to 300 degree, and the shoulder joint is up to 130 degree, that is limited to that position, and the elbow is maximum about 90 degree. 90 degree means that is both the directions, and the wrist roll, that is about 90 degree, that is clockwise and anti-clockwise directions about 45 degree, and the wrist roll can roll up to 180 degree, that is clockwise and both clockwise and anti-clockwise direction. If I have kept all such things in a position, and if I put the click button here, I can get the position of the end effector in the transformation matrix. With our calculation, we can find whether the values are right or not. The manipulator position, this is one of the important thing we need to discuss. The manipulator position is shown in a 3D graphical representation for every submission of joint values. We can find the exact location of the manipulator in three-dimensional values like this. Robot kinematics involves computing the end-effector's position from the joint angles and vice versa for controlling the position of the robot. The product robot has 5 degrees of freedom, as I mentioned earlier, and the ability to grip with its 2 fingers. The view can be rotated about a point by keeping the left mouse button pressed and rotating the mouse like this. The view can be translated by keeping the right mouse button pressed and translating the mouse in desired direction. The scroll button or the middle button of the mouse that can be used for zooming purpose like this. So this is about the simulation part of forward kinematics of Mitsubishi MoveMaster RM-501. Thank you very much.